Elon Musk's companies, particularly SpaceX and potentially his new aerospace venture, may or may not prioritize making sixth-generation fighter jets over national security and ethical considerations. Elon Musk is ambitiously venturing into aerospace with a sixth-generation fighter jet that promises to redefine aerial combat through groundbreaking technology and capabilities that seem almost otherworldly. Could this radical innovation render current military strategies obsolete? And what secrets lie behind the design and functionality of an aircraft that could change the face of modern warfare forever? Join us as we delve into Elon Musk revealing sixth-generation fighter jet that defies all physics. Elon Musk has not been directly involved in the manufacturing or designing of traditional fighter jets, nor has he launched a military aviation project with the aim of creating traditional fighter aircraft. His weight in aerospace and military circles grows from his visionary analysis of what the future of the skies in combat would look like, in addition to his general interest in space and rocket technology through SpaceX. Musk's comments about fighter jets went viral in 2020 when he told attendees at the Air Warfare Symposium that the era of manned fighter jets was over. He said the future of air combat would more than likely belong to autonomous, AI-powered drones capable of outrunning and outmaneuvering traditional fighters. The comments started to raise interest within the U.S. Air Force, raising hopes for unmanned aerial systems to take the dual role of companions and replacements for conventional fighters in certain missions. Musk has been blunt that fighter jet technology must be upgraded to accommodate unmanned systems that can fly on their own or function as wingmen to manned jets. He proposed developing competitive, AI-enhanced drones capable of challenging advanced fighters like the F-35. To Musk, such a method could push the boundaries of speed, agility, and decision-making that manned jets simply could never match because of human limitations. He further expanded this concept on social media to say that with a drone fitted with maneuvering autonomy, one could very easily outdo a piloted jet like the F-35, hence rendering it obsolete in many combat roles. That perspective underlines Musk's bigger belief in AI's potential to enhance decision-making and agility in critical situations, habits that have also shaped his contributions at Tesla and SpaceX. Musk's major contributions in the field of aerospace come through SpaceX, where he has managed to revolutionize rocketry with innovations such as reusable launch vehicles that drastically cut down on space mission costs. These two developments have made him an indispensable partner to NASA and the other military and government agencies concerned with space, further reinforcing the national security capabilities of the country in space. Under SpaceX, Musk initiated programs such as Starlink, a satellite-based internet service. Each one of these efforts has potential military uses, ranging from offering global communications coverage in remote and conflict-prone regions. This has placed him at the fulcrum of the debate on space-based defense, even if he is not directly getting into the manufacture of fighter jets. His views have catalyzed seminal discussions within the U.S. military, especially with regard to the NGAD program, a vision in which, later in the future, AI and autonomous drones would be able to carry out combat missions. While Musk does not fabricate fighter jets, his input about the considerations of defense and space innovations underlines a belief in the technological dividend, AI, and autonomy playing a strategic role in war. That has perhaps led military leaders to contemplate larger, high-tech, AI-driven air superiority for the decades to come. But in what ways has Elon Musk's work in the aerospace industry, through SpaceX and other ventures, potentially influenced or intersected with the field of military aviation? And what implications might his technological advancements hold for future military capabilities? Elon Musk's work in aerospace, particularly at SpaceX, relates to military aviation and developments on reusable rockets, satellite networks, and furthering military strategies. This has spinned around the orbits as a result of reusable rockets developed by SpaceX, such as the Falcon 9 and Falcon Heavy, making the launches of satellites cheaper and more frequent, thus increasing the options available to the military for access to space-based capabilities. These launches are used by the U.S. military to carry out vital missions in space, including secured communications, GPS, and surveillance, all significant components in its operations on air, land, and sea. It is this access to inexpensive and speedy deployment of satellites that reinforces national security and allows timely sets of orbital defense assets. Another huge contribution is SpaceX's Starlink, a global satellite internet network that will provide high-speed internet even in the most remote areas. Starlink has shown great potential for military use in establishing secure and resilient communication links in areas that are either remote or engulfed in conflict, where normal communications might either not be available or compromised. This network has already been tested for such purposes, which just goes to show the value it brings to deployed forces needing secure and stable communication channels in some really tough environments. Moreover, apart from this, Musk's ideas about the future of military aviation have influenced U.S. military strategy. He publicly submitted that autonomous drones could even outperform human-crewed fighter jets someday. He foresees the redefinition of air combat, where AI-powered drones attain the greatest of maneuverability and speed that no human-piloted aircraft is able to. This perspective has given birth to the deliberation within the U.S. Besides, the next-generation air dominance program of the Air Force also hopes to include autonomous drones as companions to manned jets. Musk's emphasis on AI-driven combat agrees with an Air Force increasingly interested in using drones for complex missions, potentially besides or instead of manned aircraft. SpaceX has emerged as a key player in the launch and operation of space-based defense assets for the U.S. Space Command. The assets serving national defense have also become critical due to their part in surveillance and early warning, extending military situational awareness into space. Similarly, with SpaceX, Musk extends the military's capability to monitor and respond to any new threats on the horizon, which could help reinforce defense capabilities for the U.S. and put the military in a better place for the complexities of space as a critical defense domain next to traditional air and land forces. With all this talk about the sixth-generation fighter jet, what unique and advanced technologies define this jet, and how do these features differentiate it from previous generations? A sixth-generation fighter jet is defined by a series of advanced technologies aimed at surpassing the capabilities of current fifth-generation jets like the F-35 or F-22. One major feature is advanced stealth and survivability. While fifth-generation fighters already emphasize low radar visibility, sixth-generation jets aim to further enhance stealth with advanced materials and thermal management techniques that minimize radar and infrared signatures. AI and autonomous systems also play a central role in sixth-generation jets, enabling capabilities that go beyond traditional piloted operations. These aircraft are expected to incorporate AI for autonomous decision-making, allowing them to handle threat analysis and control unmanned loyal wingman drones. This setup enables pilots to focus on broader strategic goals, leaving tactical adjustments and some in-flight operations to the AI. Another defining characteristic is sensor fusion and battlefield connectivity. Sixth-generation fighters will function as network nodes, sharing real-time data with other aircraft, drones, and ground systems. The seamless integration across platforms is intended to provide a more cohesive and comprehensive view of the battlefield, which is essential for complex, modern warfare scenarios that rely on quick, coordinated actions. Directed energy weapons are also expected to be part of these new jets, offering advanced defensive capabilities against incoming threats. These high-energy systems, such as lasers, may be used to counter missiles or other aerial threats, providing a potentially unlimited supply of ammunition in certain situations, unlike traditional munitions, which are finite. Additionally, sixth-generation jets are designed for long-range operations. Their ability to travel extended distances is crucial, especially for theaters like the Pacific, where operational ranges are vast. These aircraft will feature enhanced endurance, allowing them to conduct missions without frequent refueling support. Finally, enhanced agility and speed define sixth-generation jets, with adaptable engines capable of adjusting power and efficiency to suit various mission requirements. These engines facilitate high agility and sustained supersonic flight, known as supercruise, which is important for rapid deployment and response times in dynamic combat environments. Overall, sixth-generation fighter jets combine stealth, AI autonomy, advanced connectivity, directed energy options, and extended range to achieve superior air dominance in future combat scenarios. Seeing that these jets offer these many fantastic features, which countries are currently at the forefront of sixth-generation fighter jet development, And how are they each approaching the unique challenges and requirements of these new aircraft? Numerous nations are currently focusing on advancing sixth-generation fighter aircraft to secure air supremacy using state-of-the-art technologies. At the forefront is the United States, with its next-generation air dominance, also known as the NGAD initiative, that aims to develop a range of unmanned aircraft capable of functioning in challenging settings and anticipated to be operational by the 2030s. The next-generation air dominance model of the U.S. Air Force represents a forward-thinking approach to aerial combat by integrating piloted fighter aircraft with advanced drones, referred to as wingmen. This innovative design enables the manned fighter to work in concert with unmanned systems, enhancing situational awareness and operational effectiveness in complex environments. The wingmen drones are intended to carry out various tasks, such as surveillance, electronic warfare, and even direct engagement, allowing the piloted fighter to focus on more strategic objective. The United Kingdom is currently working with Japan and Italy on a project to create the Tempest fighter aircraft. This collaborative initiative is focused on launching a state-of-the-art sixth-generation plane by the mid-2030s. The Tempest fighter is anticipated to incorporate cutting-edge technologies, including intelligence features and directed energy weapons. Moreover, it will boast capabilities and multi-platform networking functions. Japan sees this partnership as an opportunity to strengthen its FX fighter program in alignment with its defense strategies in the Asia-Pacific region. In the 2040s ahead of us lies the Future Combat Air System, also known as FCAS, an effort between Germany, France, and Spain aiming to develop a cutting-edge combat system with both manned and unmanned components anchored by a sixth-generation fighter aircraft at its core. This initiative is set to integrate AI-powered command and control features, along with information exchange and adaptable weapon systems, to enhance the military prowess across Europe. China is also reportedly advancing its sixth-generation fighter, potentially evolving from its existing J-20 stealth fighter. Although details are limited, Chinese sources suggest it may feature AI-driven capabilities, hypersonic weapons, and further advancements in stealth technology, positioning it as counter to U.S. and allied developments. China aims to deploy its sixth-generation fighter by the mid-2030s, underscoring its commitment to competing in high-tech military aviation. Russia, too, is heavily invested in next-generation air combat technologies, which are believed to be an extension of its Su-57 program. Russian officials have indicated that their upcoming fighter will likely incorporate directed energy weapons, hypersonic capabilities, and advanced AI. Despite setbacks with the Su-57, Russia remains determined to advance its air combat technology and compete in the realm of sixth-generation fighters. Each of these national programs is focused on leveraging AI, autonomous systems, advanced connectivity, and directed energy options. This reflects a global shift towards multi-platform, networked air combat designed to operate in contested environments, ultimately aiming to deliver a strategic advantage. These jets, although advantageous, have their disadvantages. But what are some of the significant drawbacks and challenges that come with the development and deployment of sixth-generation fighter jets, including financial, technological, and ethical concerns? And how might these factors impact the future of these programs? What makes sixth-generation fighter jets so enticing is that they are expected to bring revolutionary performances to the fight. But it also means that these fighter jets have a number of inherent disadvantages. One eliciting factor is the high development and operational costs of these networks. These jets demand heavy capital investment. Costs are further exacerbated by the incorporation of high-end technologies such as AI autonomy, directed energy weapons, and the use of advanced composite materials. For example, the next-generation air dominance fighter in the U.S. Air Force will most probably command prices of $300 million or even more per unit, making the series probably a low one. This would place pressure on defense budgets and limit fleet numbers, making them an expensive solution to national security. Related to the first point, there is also the issue of having to maintain and control complex technology. Sixth-generation fighters are highly dependent on untested, sophisticated systems like AI-powered autonomy and extensive networking for data sharing and communication. Although these technologies increase awareness on the front lines, they come with weaknesses. The important networks could be hacked or experience other failures that affect their performance and could expose aircraft to threat. Another difficulty of the sixth-generation development is the security and stability of corresponding technologies as they become more sophisticated. The feature is also important because advanced capabilities of the jets mean that pilots need to undergo elaborate training. For using sixth-generation aircraft, a pilot is not only required to maneuver his aircraft, but also a loyal wingman drone and handle the systems that are AI-enabled. This double-skill approach causes a lot of training, and training is synonymous with cost and time. Such specialized training could put a constraint on the number of talented pilots that are available, thereby having an effect on the overall readiness of those air forces armed with such aircraft. However, issues concerning maintenance and logistics are operational hurdles because of the complex nature of assimilated materials and systems in the sixth-generation fighters. Technological devices such as adaptive engines, stealth coatings, and directed energy weapons need special care in terms of maintenance, which would, in turn, result in longer durations of maintenance and the attendant high costs. The complexities involved in repairing these systems may also require advanced facilities and specialized personnel, making maintenance a costly and time-intensive process compared to previous generation fighters. Finally, the introduction of autonomous and AI systems brings ethical and strategic risks. Autonomous drones and AI-assisted systems have the potential to make decisions independently, which raises ethical concerns around human oversight in lethal operations. There's also a strategic risk in relying on autonomous systems, as any malfunction, misinterpretation, or hijacking of these systems could lead to unintended engagements and even escalate conflicts. These ethical and operational uncertainties add another layer of complexity to the deployment of sixth-generation jets. In conclusion, those statements reveal that, despite substantial potential benefits, sixth-generation fighters generate many financial, logistic, and ethical concerns that might diminish the efficacy of these solutions and provoke queries concerning the human role and autonomy in aerial combat systems. As sixth-generation jets are designed to incorporate AI and autonomous capabilities, will they work in partnership with drones or eventually replace them? Elon Musk has not personally taken part in the direct advancement of sixth-generation fighter jets. However, he has opined heavily on what the future of aerial warfare looks like and the incorporation of drones into the model. This is something that Musk believes will continue to play out within air combat, pegging his bets on drones, especially those driven by artificial intelligence. Speaking during various forums, including the Air Warfare Symposium in 2020, he argued that towing the line of manned fighter jets is on its way out. Despite this, he argued that unmanned aerial vehicles or drones may be better manned jets, referring to the speeds, quick decisions, and agility limitations of human pilots. In his vision, Musk has brought up the idea that drones can act both as wingmen to the traditional fighter jets and maybe even replace the latter in some way. He sees the possibility for drones as supplementary machines for manned aircraft or as combat machines separate from manned aircraft, which would provide more opportunities for maneuver and less risk for pilots. Even though Musk's companies are not creating regular fighter jets, some of the technology and capabilities engaged by SpaceX and other related companies have an application to military aviation. SpaceX is known for mechanically recyclable rockets and artificially intelligent systems for orientation and choice. These innovations could be used as a basis for the creation of the new fully or partly unmanned military drones. Moreover, Musk's focus has repercussions for drones, as he supports the use of AI in military systems by stating that it improves their performance and function. Musk must have seen utility in drones as a subset of his general fascination with the use of technology as a tool to solve complex problems. To him, self-directed systems are ways of improving military capability and at the same time reducing human dangers. This aspiration for advancing AI technologies in both private and Army sectors is concise, with volumes of pushing the limits in IVF success rates. Musk has caused debates in the military circles, including in the United States Air Force, over the use of unmanned aerial vehicles in the future airborne combat systems. They help to discuss the Next Generation Air Dominance program and other similar programs. While the sixth-generation jets do not involve Musk and his companies as producers, his concept of future air combat emphasizing drones, will likely change the strategic use of the air forces. Musk's creative visions, especially via SpaceX and other allied native space firms, can bring revolution in specific observation of aerial warfare, emphasizing on drones and AI. This turn toward the further adoption of drones is not only an academic discussion to discuss, it is an ongoing evolution within the military hierarchies that may alter the character of warfare. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.